Hello. You are probably struggling with SMCR and you do not know where to begin from. It is an overwhelming course. I'm here to help you. I'm here to give you a head start into understanding what the fuck this course is saying. Hello, my name is Izaki. I'm the guy who created the mega table, and I teach stats for a while now, among other things I do in my life, like playing spike ball. So the difference between descriptive statistics and inferential statistics is a very important distinction for us to make in order to understand SMCR. SMCR is, of course, about inferential statistics. So let's differentiate the two. First, descriptive statistics is when you can literally go and ask every single person, about a piece of information, and then you don't need to make any inferences about what the results of your survey is. So for example, if you want to find out the average height of people within the communication science course at UVA, well, we have around 300 students, so we can go and ask all 300 students, hey man, what's your height? One by one. Then we add up all these heights, we divide that by 300, or the total amount of participants, and then we have a precise, exact average of what the average height for communication science students is, right? Let's say 173 centimeters. Cool. What about an entire country, though? Well, when it's an entire country, in descriptive statistics, what you would do is you would get, all the 17 million people live in the Netherlands. Let's say you want to find out the average height in the Netherlands. And then you add up all the heights and then you divide that by 17 million. And then you have the national average for the Netherlands, right? And then you have the precise number for the Netherlands, right? No, because it's very difficult. Like, you can't ask 17 million people to do a survey. It's fucking impossible. So how do you solve that? Well, you solve that with inferential statistics. Well, which is basically there's a population of 17 million people in the Netherlands, and then you get a sample from that population, say of 1,000 people. And because that sample was randomly selected, that is, you chose randomly set, 1,000 people among those 17 million, well, then we have all the reason to believe that this sample is representative of that population and therefore has somewhat of an average that could be close to the average of the population, which makes sense. So you ask from the sample, what's your height? You add up all the heights and divide that by 1,000. And then you have this height, which is 180 centimeters average height for the Netherlands. Is that real? Well, we don't know, because we don't know exactly what the answer would have been if we were to ask every single one of those 17 million people in the population. We only know about these 1,000 people. So the thing is, they were randomly selected, right? So we have all the reason to believe that it's good, but there's this thing called random error, right? Sometimes when you're randomly selecting people, it could be that you end up with way too many tall people in your sample than there actually are in the real world, right? So for example, imagine if we just had one too many tall people in our sample, that could really pull our average up, and that sucks. That's what we call random error, right? They could be too tall or too short or whatever. There's a bunch of maths that goes behind the scenes in SPSS that we don't have to cover right now, and frankly, not any time in the course, which is great. But we do have to understand the theory of how it works. So what SPSS gives us when we're trying to find out what the population value is, what the population average is, SPSS gives us an average. So SPSS will say, well, based on this value of 180, we can be confident that the average of the population is going to be between 178 or 182. And it's fair because, maybe we have a couple, one too many tall people in our sample or one too many short people in our sample. And that's problematic. But all of this is the definition of inferential statistics. Cool. In inferential statistics, your results are given in ranges, therefore. So we're 95% confident that the average height is, in the Dutch population is within this range. So we're not saying that the average height is that 180 that we found here. No, we're saying the average height is between 178 and 182. Could be 179.2, could be 181.4, could be any value within this range.